So hey guys, I realize that a lot of us have been struggling with these assigned studies, so I decided to make a video on apoptosis. To start out, I guess there's three ways in which the cell can die. You'll see necrosis, autophagy, and apoptosis. So in necrosis, the cell will get so much DNA and protein damage from like heat, radiation, exposure to toxins, that basically the cell cannot function. It can't maintain homeostasis anymore, so this will result in cell death. And what you'll see is the cell will actually lyse, it will release all its proteases and enzymes, and you'll see bystander damage. Okay? With autophagy, the cell is actually, it's in a starved state, and so when it's starved, what it tries to do is it tries to conserve energy. So what you'll see in this is like the cell actually begin to shrink, and it'll form membranes around some of its organelles as it tries to digest them, just to conserve energy. In a way, this can conserve the cell, and actually, if energy does become available again, it will survive. But if it's prolonged enough, it will also result in cell death. But in this case, you really don't see as much bystander damage because the cell should be smaller by now. It's kind of like shrunk. With apoptosis, it's highly regulated death. So the cell actually receives signals to transcribe RNA, which results in proteins that do multiple functions. So what it will do, it will degrade the genome, and it will actually degrade the genome in specific spots. So what you'll see is combinations of 180 base pair stretches of DNA. So if you run like a PCR with necrosis, what you'll see is you'll just see a continuous band because the DNA is just broken up randomly. But when you run a PCR on apoptosis, the bands will be highly regulated, like a sequential order. So this would be like 180 base pairs, 360, 540, 720, right? And the reason the cell does this is, say that the cell is infected with a virus, and so there's viral DNA in there. Basically, the body wants to make sure that you degrade that viral DNA so that it doesn't go on and infect the phagocytes that phagocytose these apoptotic bodies once they're finished degrading. So you get the DNA. What you'll see is the cell membranes, and also the nuclear membrane will begin to shrink. And finally, what will happen is there'll be double membranes will form around all the organelles within the body, okay? And these will have caspases in them, which are both basically proteolytic enzymes that break down the cells, and they're nicely contained within these apoptotic bodies. And the apoptotic bodies actually have signals on them so that phagocytes will recognize them, and they will engulf them. And basically, it's a very clean way of the cell dying, and there won't be any bystander damage.